ancient underground water suggests Mars may have been habitable longer than previously thought. The idea that Mars once had a dense atmosphere and flowing water, making it potentially habitable, is well established. However, around 4.2 to 3.7 billion years ago, Mars' rivers, lakes, and global ocean began to disappear due to solar wind eroding its atmosphere. This has led scientists to question how long Mars remained habitable. Some argue it ceased being habitable billions of years ago, while recent research suggests Mars experienced periods of habitability that lasted for eons. NASA's Curiosity rover, exploring the Gale Crater, has provided valuable insights into Mars' past. Scientists at New York University Abu Dhabi, NYU, have uncovered new evidence that billions of years ago, ancient sand dunes within the crater gradually turned into rock due to interactions with underground water. Their findings, published in the Journal of Geophysical Research, Planets, indicate that Mars may have been habitable much longer than expected. The research was led by Dimitra Atri, principal investigator of NYU Center for Astrophysics and Space Science, CAS, with assistance from Vignesh Krishnamurthy, a fellow CAS researcher. They were joined by James Weston, research instrumentation scientist from NYU's core technology platforms, Marie B. Al-Handawi, postdoctoral associate from NYU's Smart Materials Lab, and Professor Pants Namov from NYU Center for Smart Engineering Materials, the Research Center for Environment and Materials, and NYU's Molecular Design Institute. The team examined dunes in the Stimson Formation, SF, a system of wind-blown sand and sedimentary rock in the Gale Crater. Curiosity rover observations have confirmed the presence of these lithified formations at this location. Given the dry conditions in the Gale Crater, these formations likely formed during the Noachian period, 4.1 to 3.7 billion years ago, when extensive flooding is believed to have occurred, including rivers flowing into the crater. By accessing data through the Mars Science Laboratory's Curiosity Notebook, the team compared it with field studies of rock formations in the UAE desert, known to have formed in the presence of water. They determined that the SF was the product of late-stage aqueous activity, formed from interaction with groundwater from nearby mountains. This interaction left behind minerals like gypsum, a soft sulfate mineral found in Earth's deserts. These findings align with previous research by Krishnamurthy and Atri, presented at the 10th International Conference on Mars, which examined data on nearby green-hue pediments. Both studies suggest that these underground water systems led to the creation of unique formations, potentially containing preserved remains of ancient bacteria, which could significantly impact the search for past and present life on Mars. This research not only sheds light on Mars' evolution but also highlights these sites as promising candidates for future missions seeking life on the planet.